Welcome back. In this case study, we will go into more details about how abstract data types can be used to improve the modularity of programs. So in this case study, we will define a module type, an interface, that corresponds to what is expected from a module that provide a data structure for dictionary with the function that works on dictionaries. So it's a little story. Let's imagine first that the designer of the interface wrote something like that. So it says that the type for dictionary is an association list, so a list of pairs with a key and a value, and then there exists an empty dictionary, a function that takes a dictionary, a key and a value and returns a new dictionary that contains all the keys of the previous dictionary plus the key, the new key related to the provided value. There also exists an exception that is raised when a lookup failed. And so there is this lookup function that takes a dictionary, a key, and returns a value associated to this key in the dictionary if it exists, or raised not found otherwise. So this is a module type, and it is accepted by the OCaml compiler. Now, this is an obvious implementation that I won't detail for the signature, and we can write a client that makes use of all this definition to define a module that store some relation between name and integer, and it works. So everything looks fine, except that the interface is not well designed. Indeed, imagine the following scenarios. The developer of this module noticed that finally this implementation based on association list is not valid because it's not really efficient. The lookup function is linear in the size of the list. So he wants to change the data structure that implements the dictionary. But unfortunately, the interface mentions the way the dictionary is implemented. So the client has used this information to implement this value in this module. So here, force is a list, so it's valid to apply list.map function. So something is wrong here. The evolution of the first module, the implementation of the dictionary, cannot be done without changing the client. So imagine that there is a 100 client for this module, you will have to change 100 clients just because you have a badly designed interface. So imagine now that we have made this type abstract, then at the first place, it would be impossible for a client to write a code like that. Let us check that the compiler rejects this code. Oh yes, for the reason that are now clear to us, dict.t is an abstract type, so it's, even if it is internally implemented as a list, it's not a list from the outside. So we have to remove this definition. And now we can continue the story and change the implementation of the dictionary to be, for instance, a binary search tree. Again, I won't detail this implementation, except that it's a valid implementation for dictionary. Just have to know that, and indeed the compiler checked that the module satisfies the dictionary signature. The nice thing is the fact that you can reuse exactly the same code for the client, and it is a valid code. Just a final remark. Notice that when I evaluate this module, the exception dict not found is raised. So one of the lookup here failed. But the exception is not really informative, because I would have loved to have here the name of the key that was not found in the dictionary. So all this modular programming is very nice, but still, some points can be improved. The first one is the fact that the exception that is raised when a lookup has failed is not very informative. We would love to write an exception declaration mentioning not only the fact that the key is not found, but which key has been not found. Yet, that's not directly possible in OCaml, because exceptions cannot be polymorphic. Also, our dictionary implementation based on trees and lists are using the default polymorphic comparisons of values that OCaml provides, but sometimes it can be convenient to define another comparison, and that's not really possible in our implementation. Finally, in the client, the reference to the module dict is hard-coded into the code, so that you can't change it afterwards. Delaying this choice would make the client more reusable, because the same code could be used with different configurations depending on the implementation of dict that we want to use. In the next sequence, we will discover functors, and they will solve all these issues.